Welcome to qnawire.
So we can say that the angular displacement in terms of time is equal to 4t minus 3t squared plus t cubed. For part A, we want to find the angular displacement in terms of time. This would simply be equal to the derivative of the, we want to find the angular velocity in terms of time. This would be equal to the derivative of the angular displacement with respect to time. This would be equal to 4 minus 6t plus 3t squared. And we can say that the angular velocity at t equals 2.0 seconds. This would be equal to 4 minus 6 times 2.0 plus 3 times 2.0 squared. This is giving us 4.0 radians per second. This would be measured in radians. For part B, the angular velocity at t equals 4 seconds would be equal to 4 minus 6 times 4.0 plus 3 times 4.0 squared. This is equaling approximately 28.0 radians per second. For part C, we want to find the average angular acceleration between 2 and 4 seconds. So we can say that the angular velocity at 4 seconds minus the angular velocity at 2 seconds divided by 4 seconds minus 2 seconds. This would equal the average acceleration, the average angular acceleration between this time interval. This is giving us, we reference part A and part B. So we have 28 minus 4 divided by 4 minus 2. This is giving us approximately 12 radians per second squared. For part D, we can then say that the angular acceleration is going to be, the instantaneous angular acceleration would be equal to the derivative of the angular velocity with respect to time. So this is going to be equal to -6 plus 6t. And so we can evaluate the angular acceleration at t equals 2 seconds. This is equaling -6 plus 6 times 2. This is giving us 6.0 radians per second squared. Radians per second squared, of course, being the units for the angular acceleration. And lastly, for part E, we want to when we evaluate the expression in part D at t equals 4 seconds, we can then say that the angular acceleration at t equals 4 seconds would be equal to -6 plus 6 times 4. This is giving us 18 radians per second squared. And then we can say, essentially, we're noting that our answer for the average angular acceleration does turn out to be the arithmetic average of a sub 2, alpha sub 2 and alpha sub 4. But this, this of course won't always be the case. So we can say that essentially 18 plus 6 divided by 2, this is equaling 12 radians per second squared. And we note that this is giving us the same answer as the answer. However, just note that this isn't always the case. This is just based on the equation that they gave us initially here. So in this case, it does, the average angular acceleration does equal the average angular acceleration when calculating it from the angular velocities. However, again, this is not always the case, and you do have to take the derivative in order to find the instantaneous angular acceleration. That is the end of the solution. Thank you for watching.